My name is Paul McCarty. I am currently the head of head of research at Safety. Safety is a small supply chain security company based in Vancouver. That's not why I'm here, though. I'm here to talk about open source malware and why it's invading our security toolings. I have worked for a lot of large organizations. I've worked for a lot of startups. And the problem is the same for both of those sizes, regardless. Just a different scale. So I like to write a lot of open source tools. I'm a very prolific. Anyhow, I do a lot of open source stuff. So the stuff on the left is all my tooling. These are things that I've written. I'm actually really super excited about Gimme Pats, Super Confused, and Malice. I haven't even dropped Malice yet. It's got like 0 stars on GitHub right now. Malice, you say that Malice, basically what it is like helps you identify malicious open source packages in the NPM ecosystem or the PyPy ecosystem. And I'm going to be officially kind of launching that next week. But all the stuff on the left is mine. The stuff on the right are projects that I hack on, that I like working on. And in particular, I want to call out the fact is, who here has used the OpenSSF's malicious packages repository or osv.dev? All right, dope, sweet. I was the main contributor. I was the top contributor for the last 6 months to the malicious packages repository, but a guy from AWS has now overtaken me, so I'm number 2. Oh, I'm going the wrong way. Sorry. All right, here's the takeaways that I want us to come away with today. How does open source malware evade security tool detection? Basically, part of the weird thing about open source malware is that it's not just the source code itself, it's the source code and the package ecosystem and all the things wrapped around it that combine together to make this amazing malware experience that we see. It's very different from kind of traditional binary-based malware. It targets developers in CI/CD pipelines. Why does it do that? Because there's not many security tools there, right? What are the number 1 and 2 exclusions for EDR tooling? Like when an enterprise has EDR tooling, who are the 2 personas in the organization that have the most exclusions? Anybody? Developers? Who else? Yep, very good. Oh my gosh, you guys have been reading my notes. Yeah, that's right. Executive suite and developers. So why do we think that they're targeted? Well, there you go. And the reality is that there's not many good security tools that address this space. Software engineers think that they've got coverage from SCA products. Security teams think they've got coverage from EDR and other security tools. In fact, neither is true. And finally, the reality is that security teams don't understand the threat. Engineering teams maybe theoretically understand it, but security teams just don't understand the threat. And that's based on my personal experience. So why we only have 25 minutes today, right? Why are we here to talk about NPM? Well, bad guys love NPM. Why do they love NPM? Well, NPM, first and foremost, it was built in a time, 2011, 2012. It was built in a time before, I call it before security. If you look at the original kind of notes and documentation from NPM, you'll see that security, right, wasn't something they were actively thinking about. And that's not a criticism, it's just an observation of the reality. In a similar way, the founding people of the NPM ecosystem in JavaScript itself, and especially Node, had this concept of no batteries included. Have you guys heard this before? The idea of JavaScript, no batteries included? It's actually, if you go and look at the original documentation from the Node team, they talk about this a lot. Basically, the idea here is that we don't want JavaScript to do anything itself internally. Now, that's different. In 2025, JavaScript now has a bunch of internal commands, and you don't need to pull in all these libraries like you used to. But by definition, it was built to basically require you to use things like left pad and is even and is odd and all these ridiculous things, right? And that's part of the problem, is it was built to do that. And you'll see in a slide in a few minutes why this comes back to haunt us. All right, next, why is NPM so crazy insecure? Brian Fox from Sonatype calls the install scripts in NPM He calls that RCE by design. And the reality is that the post and pre-install scripts in NPM were perfectly built to deploy your JavaScript. So basically there's a pre-install script that you can call. Not every package.json calls it, but if it does, guess what? Before the package contents get installed, it does this thing. Similarly, if there's a post-install script, after it's installed, it does a thing. So imagine a scenario where somebody writes some super sweet malicious content, and then the post-install script goes ahead and runs it for them. It's like the perfect RCE pipeline. Next, the barrier to entry is low. When I did my 4-hour workshop yesterday, before I started the class, I timed myself to see how long it took me to create a new Gmail account, a new GitHub account, and a new NPM account. And it took me less than 5 minutes, right? The ease of onboarding in those ecosystems is amazing. So that means that somebody can create an NPM account in a minute and immediately publish packages, right? And then they can use some of the other things that we're gonna talk about here in a second to make themselves look better, to make themselves look like they're more realistic and legit. Anyone can claim a namespace. Not only can you create an account really quickly, but anybody, if at Microsoft and NPM is available, guess what? You can take it. You don't have to prove that you're from Microsoft. You don't have to prove that your email address ends in Microsoft.com. If it's available, you can take it. And the way that attackers use this is when there's some new hot thing, the first thing they do is they go and grab the @ scope for the thing, like @immutable or @Solana or whatever the hell it is, right? Anybody can grab a namespace. Package metadata can be faked. This is crazy. Like, this still blows my mind. Package metadata in NPM, about half of those fields can be faked, right? And what I mean by that is the author field. You can put anything in there you want to. You can put Linus Torvalds. You can put anything in there you want to. Similarly, you can do the same thing with the Git repo. You can point at any Git repo you want to. All right, sweet, we got some more people coming in. Sorry, yo, I started early, but that's okay, you're here for the good stuff. So this makes it really easy to make like really legit looking lookalike packages because you can literally take the original package, reuse it, it points at the original legitimate GitHub repo, it points at the original legitimate author. The only thing that changes is the NPM user. All right, account takeover in NPM is really easy. Still to this day, it doesn't require you to, NPM doesn't require you to use 2FA or MFA. It does if you're one of those, super important maintainers, but still doesn't require if you create an account. And unfortunately, it takes a long time to remove malicious NPM packages from the registry. In fact, I found one in late December of 2024. I let NPM know about it, and when do you think that got removed from the NPM registry? I like it, it hasn't. I like that guy. That's the winner right there. No, they took it out in May. December to May. So just say this out loud. I let them know it was vetted malicious in December of 2024, and it was still in the registry. You could download it and get pwned by it until May of 2024. Frankly, it's a shit show. GHSA and NPM don't track. So GHSA is GitHub Security Advisory, NPM is NPM. They don't track malware data, important things. So for example, they don't track, when GHSA marks something as malicious, all they do is they add this tag to a malware. There's no mention of the author. There's no mention of any other important information. It doesn't even say what it does. It just says that package is malicious. Now, why that's a problem is I can't then pivot from the author into other packages that author has created, right? And that's a real problem. We doing good so far? I'm not going too fast? All right, sweet, like this. All right, so remember how I said you can get a namespace and all those other things? Well, according to a Sonatype study, 98.5% of all malicious packages they took a look at exist in NPM. Less than 1% is in PyPy. Although PyPy is growing, all you Python fans, don't worry. Your malware day in the sun will come. The reality is that most of the malicious packages exist in NPM for all the reasons we're going to talk about today, right? 98.5%. Now couple that with, boom, this is data from GitHub. What this shows, my bag is in the way, so I apologize. What this shows is the little black columns on the left represent how many direct dependencies a particular language package in GitHub has. So let me say this a different way. GitHub basically took a look at all the repositories in their ecosystem and said, when I find a JavaScript package, project, not package, project, how many direct dependencies does it have versus how many transitive dependencies does it have? So let's look at PHP. Nine direct dependencies, 70 indirect or transitive dependencies. JavaScript, 10 direct dependencies, 683 indirect or transitive dependencies. The reason this is so important is because this idea of no batteries included means that the average JavaScript package pulls in more transitive dependencies than all the other languages. If you were to add all those transitive dependency numbers up, still not as big as JavaScript, all right? This is how the problem inside of NPM and inside the JavaScript ecosystem is compounded. Need some water, yo. All right, I'm good. All right, so how does open source malware evade security tools? First, let's start by talking about the fact that most open source malware is an interpreted language. It's JavaScript, Python, Go, what have you, right? And sure, Go can be compiled, but the reality is that most of these malicious packages are just source code. They're just JavaScript, right? And because 98.5% of the malicious packages, roughly speaking, are malicious, are in the NPM ecosystem and are JavaScript, that means that you're not really looking for binaries anymore, right? You're dealing with interpreted source code. And a lot of the common techniques, the muscle memory that malware analysis reverse engineers have just does not apply, right? So if you spent many years reversing malware, many of those skills just don't apply to when you start doing this for open source malware. Also, the reality is that the payloads, because they're packages, are highly iterative. So for example, you'll see later on, actually I don't know if that slide's in this one, but the point is that bad guys can change their payloads from one version to the next in the space of just a couple of minutes, right? So for example, if version 1.0 has a C2 of this IP address, the bad guy, if somebody burns that IP address, the bad guy can push out a brand new version of it and has a different C2, has a different hard-coded IP. They can change everything so quickly. We are so used to dealing with like a binary, and we know that that binary has got, does these things, and it takes a while for the bad guys to push out a new version of that. With open source malware, they are iterating often. I looked at one particular package that had been around for about 2 months, and it had 19 versions. And in those 19 versions, it had 3 or 4 major different changes in both the payload structure, how it encoded the payload, and the C2 that it called out to. And finally, I'm sorry, but anybody that works at some of these sandboxes company, you're not doing a lot for me from a JavaScript perspective, right? For the free versions of these products, I can't even call Node to run interpreted JavaScript. So using these kind of traditional sandboxes like AnyRun and Joe's, those are great things. I use them all the time, but they don't really do a lot for JavaScript or interpreted languages. Oops. All right, cool. God damn. There we go. Obfuscation. I heard somebody at RSA on stage say obfuscation equals malicious. Like if you see obfuscated code inside of a package, it's malicious. That's just not true. It's just not true. There's lots of reasons that people obfuscate their source code now, and I'm gonna guess that you guys have an answer, but what's one good reason that somebody would obfuscate their JavaScript? What was that? That's right, yeah, they just don't want to disclose it, right? And the reality is most of the time that's because they've put business logic that they don't want to expose in the JavaScript, right? And so they obfuscate it for that reason. Totally legitimate, but that means that you can't, if you see obfuscation, you can't just assume that equals malware. You can't assume that it's malicious, right? And the problem is there are some malicious detection engines out there that will see obfuscation and label it as malicious, and that's just wrong, right? It's a bad assumption of intent. There's lots of very legitimate reasons to have obfuscation. Now here's the problem is that there's lots of different obfuscation techniques, and bad guys have really gotten good at layering those different obfuscation techniques on top of each other to make very, very difficult to comprehend code. I don't have enough time today to go into all those obfuscation techniques, but control flow flattening and control flow reordering is a very, very difficult obfuscation technique to deal with. It's basically where you take kind of a logical order of the source and you flip it around using a bunch of conditionals and stuff. So basically when you look at it, especially after you use identifier renaming or variable renaming, it just makes it so you can't understand the kind of context and order of the code. It's very, very productive. And because there are so many obfuscation techniques, we're seeing some crazy weird techniques now where people are they're encoding everything to emojis and all kinds of stuff, and then they're layering other obfuscation techniques on top of that, and it just makes it super crazy hard to figure out what's going on. Luckily, now I'm a bit of an AI skeptic, but I'm gonna say that Gemini lately has been doing a really, really good job of helping me understand what this code is doing, right? You can't trust implicitly what it says, you have to verify, but the reality is this is one of the few places where I see LLMs like really kicking ass and taking names. It's understanding what the source code is doing and then translating it for you. And finally, obfuscation, typically, LLMs aside, typically it means that a human being has to get involved. And that slows down the process. That makes it really hard for you to figure out what's going on and whether or not, because you're trying to identify, you're trying to figure out, there's some signals here, it makes me look like it's maybe bad, but I don't know, right? I don't know. And then you have to spend time figuring that out. All right, what's great about JavaScript is it runs in the browser, right? A lot of the malware nowadays is targeting specifically to run in a browser. The most common example right now is our malicious packages that are targeting crypto developers. So basically what they want you to do is they want you to import their malicious package into your web app, right? You're like building this crypto thing. They want you to import that library into your web app. And then it does what it says it does. It does, logs crypto events or whatever the hell it does, but it also does the bad thing, right? The reality is that the browser is an attack surface that we really don't have an answer for, right? We really don't. JavaScript is also flexible, Obviously you can target devs, right, in the front end and, kind of targeting the apps that they're building, but it can also target the back end. And that's the thing about JavaScript, it's a very flexible language. By the way, I'm not a big fan of JavaScript, so you might think that I am up here talking about it, but the reality is it is a very flexible language, can be used in multiple ways. And when you are targeting the developer of crypto or what have you, what are you doing? You're trying to target, wallet files, you're trying to target cookies, access tokens. It's just a very, very rich environment. And I'm now seeing malicious packages. Like, for example, the North Koreans for a long time there were specifically looking for like Solana tokens, and they were very specific, very targeted about what they were looking for. Now, they've got conditional logic. They say, hey, look, do you see any Solana stuff? Nope. Okay, did you go and see some Ton stuff? Nope. Do you see some, Starkweb? They're looking for things, and if they find it, then they'd go further. It's becoming a lot smarter and able to be used in more, looking for more stuff. And finally, our friend, browser extensions, right? the bane of our existence. I'm still, in this browser, I'm not using any, but the reality is that bad guys are able to use open source malware via browser extensions, and this is a growing threat really quickly. Open source malware targets developers in the dev environments. How does it do that? Why does it do that? It does that for two reasons. It does that to deploy the malware itself, but it also targets the developers to take over their accounts, right? It's the simplest thing. Why would you build this complex attack chain when you can just phish a developer and get their creds and take over all their shit? Why would I spend that time doing that when I could just build a much simpler path? Security tools, I can't stress this enough. Security tools, AppSec tools, are absolutely viable. They address the accidental vulnerabilities that we all know, like the OWASP top 10 vulnerabilities that we know. But they are not built, they're not built to detect malicious behavior. In my workshop yesterday, I gave copious examples of how static analysis and SCA platforms just don't find this stuff. They just don't. The reality is that, as we talked about earlier, developers have a lot of exclusions from EDR, but most of the time they just don't run security tools. They're just not running an EDR agent. Not that it would actually catch much of this stuff. But there's just this history of developers not having to run security tooling, and there you go. And developers use a lot of browser extensions, so that's another area that you can get to them. And finally, my favorite, all this AI stuff. I'll talk about this a little bit later, but the reality is bad guys right now, for a while there, if there was a package on Python that talked about MCP, there was probably a 50% likelihood that that was malicious. Like, it was just crazy how much the bad guys were targeting MCP specifically. But all the AI tooling right now is being targeted. Bad guys like to target CI/CD pipelines. So in that scenario a second ago, we're talking about targeting a developer and their individual laptop. But now let's talk about, we don't want to target a human. We want to target something that's going to get reused a lot of times in a CI/CD pipeline. Well, first and foremost, security tools are never running in those CI/CD pipelines. The pipelines themselves call these libraries and these containers again and again, hundreds of thousands, millions of times with no oversight. If you're using GitHub, the free version of GitHub, your CI logging goes away in 90 days, so you can't even go back and look and see if there was a bad event after 91st day, you're SOL. The amount of logging and the understanding of what logging is there is not there. So unfortunately, it's really easy for these events to get missed in the CI pipelines. And finally, continuous integration. These pipelines, it's where two really important things come together. First is your core intellectual property, your source code. It's there. And the next thing is a shit ton of access, API keys, AWS access tokens, and all kinds of other stuff, Perplexity keys, NPM tokens. The combination of those two makes that area a super rich place for bad guys to be, and that's why they are there. All right, so you want to really, really try as a bad guy. Let's pretend that you guys are all bad guys, right? Do we have anybody that wants to admit that? Are you offensive security and operate in this environment? Anybody want to admit that? All right, we got one. Me too. Me and you, bro. Me and you against the world. The reality is that much of the malicious package detection that platforms use happens in GitHub Security Advisory or OSV, the OpenSSF malicious packages repository. Many security vendors use those two things to determine if something is malicious. I've proven this again and again and again for Sneak and a whole bunch of other tools out there. So here's the thing. If you can keep your malware especially out of GHSA, you're good. And so if you're a bad guy and you see somebody like me or one of my friends who finds a malicious package and we turn it into OSV, OSV marks it as malicious. But if you then, as the bad guy, go and remove that package from NPM, you're removing yourself, right? It's never going to get into the GHSA. And so you now have saved yourself. You can reuse that name for that package again in the future, right? And you can also not burn that capability. So how do you not get detected? If somebody finds you, some smart person like me finds you, pull your package immediately out of NPM and you'll be able to, and just sit tight and you'll be able to come back like a phoenix. That's a little tip for all you offensive security practitioners out there. And finally, malware doesn't go boom, right? We have this idea of like when you detonate like malware, a binary. The reality is that the kind of malware I look at doesn't go boom. One of the craftiest open source malware packages that I looked at recently was a library that basically copied the world's most commonly used Web3 event logging library. It did everything that this Web3 package did, so it did what it was supposed to. It just also took every single event that was logged and sent it to the bad guys, right? Now the thing is that the only reason you would get pwned by that is if you imported that library. It wasn't using post-install scripts, it wasn't using install scripts. You had to actually import that into a working web application that then wanted to, send events, Web3 events somewhere, and then they would just grab them. But you would never see that malicious behavior unless you knew to take a look in that library. And so that library stayed on NPM for months and months and months, doing all kinds of bad stuff. The reality is that this stuff is interpreted. It's not, it doesn't blow up like traditional stuff does. It doesn't look like the normal stuff does, and that's why InfoSec really has left it alone. There's not a lot of people building solutions for this. And like I said earlier, part of the problem is the source code itself combined with the shit show that is NPM. You put those two things together and you get this amazing grenade. The good stuff, the good bad guys, the nuanced bad guys, the nation state actors, they almost never, somebody corrected me yesterday. If you're in the audience, I'm sorry, I won't do it again. Almost never use install scripts. Instead, they use import. All right, so bad guys like to target what's hot. And so right now, I just did it really quickly. Basically, this is just me doing some hot data take, but basically the 3 areas that I see bad guys concentrating are, from top to bottom right now are, I don't even know how to say that, Vite? Is that how I say it, Vite? Vite? Anything Vite right now in NPM or PyPy, just spend some extra time looking at it, right? Anything MCP, oh my God, take the time to look at it because bad guys are all over it. And finally, Solana. I swear to God, 60+% of the stuff I looked that talks about Solana is like probably more than that. I'm gonna go on a limb and say it's probably more than 60%. It's just straight up, it's gonna gank you. It's just malicious. So basically, but the point there of that slide is to say, bad guys are gonna target what's hot. You know, stuff that's hot. Yeah, I see a lot of phones going up here. Yeah, you guys all owe me 909. No, I'm not gonna go through every single one. Well, actually, how much time do I got? Yeah, I don't have time to go through every single one of these, but if I was a bad guy trying to, wow, that's a lot of phones. I wish I could take a picture of that. That would be sick. If I was a bad guy building open source malware and I didn't want to get caught, this is what I would do. And a couple of highlights here. And I see this right now. We'll talk about this in a second when we're talking. No, actually, I'm just going to jump ahead to the threat actors. All right, here, we're gonna talk about actual bad guys that are actually making malicious packages. And because I started a little bit early, I can go through all 3 of these. So first, let's talk about our friends in North Korea. Lazarus Group, you might have heard of them, right? No? Oh, sorry, okay, my bad. Actually, I just saw a report yesterday saying that they finally are now doing espionage. Did anybody else see this? Because they've been so singularly focused on stealing crypto. They've stolen over $2 billion worth of crypto in the last 18 months that we know about. They're 100% concentrating on it, and they've come up with all kinds of crazy ways to do that. One of the biggest that we've seen is it targets people working in the crypto space, developers working in the crypto space, on LinkedIn and on GitHub and all kinds of places. I have a friend, he's Armenian, he's been in Web3 for years, he's a developer, and so he gets hit up with these all the time. And so he's constantly, probably like once a week or once every 2 weeks, he sends me a new one. And so I just get all this juicy, brand new North Korean, I don't call it North Korean until somebody else has attributed it, so just to be clear, yep, 10-4. I don't do the attribution, other people do, but anyhow, they are flooding NPM right now, and to a lesser extent PyPy, with dependency confusion and typo squatting. So basically, they put the dependency confusion and typo squatting things there to then use in other parts of their campaign. So then when they hit you up on GitHub or LinkedIn, they can then call those malicious packages. Typically, it used to be that they were very, very specific. They were looking for a specific type of wallet file, and if it didn't find it, it wouldn't do anything. But now, they're starting to be a little bit more, they're using conditional logic, they're looking for stuff. They do like to use obfuscation. They also like to use filler code. So basically filler code is where they just drop hundreds or thousands of extra JavaScript files in there and they just make it really hard for you to find stuff. And the only time that I've actually seen an enterprise find this stuff is looking at egress outbound from their enterprise when they saw the calls out to the C2. And by the way, these are singular events, right? This is why EDR has such a hard time finding this stuff, because it's a singular event. It's not like ransomware or other things where you can look for these multiple heuristics and then tie them together, look at those signals and tie them together. This is literally a singular curl or the equivalent that calls out to them. Socket just came out with a report that talks about a tiny portion of this, but I've been tracking these guys for 2 or 3 months. Basically, I call these guys the Liran gang. They're Indonesians, but for some reason, they've all kind of decided we're going to pretend to be Vietnamese women. I don't know why, but whatever. So you can, and their OPSEC is shit. It's terrible. You can go and find these guys. If you go and search for Vaylin, and you'll find a bunch of the other threat actors involved in this campaign, And you can ultimately find them all the way. There's a bunch of them that are high schoolers in Indonesia, right? Their OPSEC is terrible. And why? Because they feel comfortable. They feel like they're not doing anything wrong. Basically, their thing, and they're not particularly technical, what they like to do is they like to attack WhatsApp. So WhatsApp now does payments, and so they do this bot thing where they basically, you come up and you connect your WhatsApp account to the WhatsApp business account, but then they create a bot that basically takes the integration that you've just used and uses that to do a bunch of monetization stuff, like look at YouTube videos and all kinds of shit. I mean, they've got all kinds of crazy ways that they're using this. All of this stuff gets exfilled back to Discord. They love Discord, probably because they're not technical enough to, to create actual C2 infrastructure. Very, very low technical skill. The Russians, we all know about the Russians, so I probably will skip this one. But one thing to point out, now, I'm not talking about the state actors, but the criminal gangs, they're actually using a lot of .ru and .sus. I think the sanctions are actually working in the sense that I am seeing a genuine increase in the use of .ru and .sus when they used to buy .coms and stuff like that. They're still using some of the cheap ones, .tops and .xyzs, but I've definitely seen an increase in .ru and .sus. And finally, bug bounty researchers. Bug bounty researchers are flooding NPM. On a month-to-month basis, we're looking at 40+% of the malicious packages that I look at are from researchers. And we need to do something about this. So I've reached out to BugCrowd and HackerOne asking them, can you change your terms of service so that we see a lot less of this stuff? But I mean, it's honestly, it spends a lot of researchers spend a lot of time trying to address this. How do we get better? We need better detection for our solutions, our SCA providers, our ASPM providers. Engineering teams need to understand how to pull vetted packages from known private registries, or I like the idea of package firewalls. So the company I'm working for is building one, but Sonatype has one. A bunch of companies we're working on them. There's an open source one too as well. You want to make sure that integrates with your proxies as well. And basically what they do is they wrap around NPM or PyPI and don't let you call malicious packages. And finally, hire people with subject matter expertise, right? This is complicated shit. Don't think that tools is going to solve this. You need to hire some people with some SME in the space. And finally, here's some open source malware. Let me move the cursor there so you can see that. Take a picture of that. These are all the places that I go to get information. Damn, that's a lot of phones. That is oh man, I wish I could take a picture of that. That's dope. I'll try to make this available on my GitHub account, so github.com/6mile. I'm from Detroit, probably so. This is some of the places that I go to get information about open source malware. And finally, that's me, Paul McCarty. Thank you so much. I appreciate it. Cheers.